In 1895, German physicist and engineer Wilhelm Conrad Roentgen discovered one of the most impactful phenomena. His find was by accident, an unintended consequence of his experiments. His discovery of X-rays paved the way for the developments in medicine, manufacturing, and even in how one's shoe size is measured, as the world sought to apply these deadly ionizing rays in ways that lead to unnecessary exposure. In today's video, we will look at the history of X-rays, how they have been used throughout history, and their dangerous and beneficial consequences. It is perhaps helpful to start with the discovery of X-rays in the Würzburg Physical Institute. It is there where Röntgen held the chair of the physics department. At that time, there was much work done with crux tubes. These were glass bulb-like tubes with the air removed, with an anode and cathode installed at either end. When a high voltage is introduced, a fluorescent light and cathode rays are produced as the electrical currents begin to travel between the anode and cathode. Röntgen was testing whether the rays produced could pass through glass. He placed a black cardboard cover over the crux tube to see whether the rays produced would leave the tube. To his surprise, he noticed that a nearby screen was illuminated green. He switched the voltage on and off, and soon realized that the source of the green hue was the crux tube. He placed various items between the screen and the tube, realizing that the rays would pass through most things and leave shadows of some on the screen. Whilst holding his hand between, he noticed an image of the bones of his hand had been produced. We now know that X-rays are a form of high-energy electromagnetic radiation. X-rays are a form of ionizing radiation, meaning it is possible for serious damage to be done to a person who is exposed to such rays. Ionizing radiation can break down and strip electrons from atoms, causing serious damage. This can alter the very molecules within cells of the body, leading to cancers or damage to tissues. When X-rays were first discovered, this danger was not known, though it wouldn't take long for science to show. There was an immediate excitement about the application of X-rays, chief amongst them were the uses of X-rays in medicine. In Röntgen's initial experiments, he realized that images of bones could be produced by the rays passing through tissues. The first reported radiograph was one taken of his wife Anna's hand, with her ring still visible. At one of the first public exhibitions of his discovery, Röntgen x-rayed the hand of renowned anatomist Albert von Koelliker, with Koelliker remarking that the X-ray ought to be named after its discoverer. Newspapers soon picked up the story, having to reassure readers that this was indeed true and not science fiction. Whilst some feared the invasion of privacy, many exalted the discovery of X-rays. X-rays were soon experimented by several doctors around Europe, with the first successful reproduction carried out by a Scottish engineer, Alan Campbell Swinton. Only weeks after their discovery, X-rays were used in a clinical setting by John Hall Edwards, revealing a metal needle in the hand of a colleague. X-rays allowed doctors and surgeons to investigate a patient's condition without the need for invasive surgery. The crux tubes were common at the time, thus allowing scientists around the world to easily recreate the process. The process was refined, with alterations made to the X-ray tubes to be more efficient. With the initial setup, as much as 99% of the energy was wasted as heat, and only a small amount of X-rays produced. What's more, they were dispersed around the entire room. By altering the shape and location of the anode and cathode, X-ray images became more efficient, clearer, and needed less time to develop. This culminated in the Coolidge X-ray tube, invented by Dr. William Coolidge, which allowed for continuous emissions and clearer imaging of tumours. Hospitals set up radiology departments taking advantage of the new technology. During the First World War, Marie Curie developed the radiological cars, bringing X-ray technology to soldiers wounded on the front lines. X-rays proved effective at assisting doctors in locating bullets and shrapnel within injured soldiers. Marie Curie trained around 150 women in their operation, and worked herself administering X-rays during the war. The use of X-rays was not only limited to the medical field. The discovery of X-rays led to a public craze in how they could be used. This new wonder process was used in all manner of fields that we now consider unnecessary. There was a fear that someone might use X-ray binoculars to leer at a lady's undergarments, leading to the sale of X-ray-proof underwear. X-rays were used to remove unwanted hair. Much like how one could visit a studio for photographs, so too could one visit bone portrait studios. But perhaps the strangest and most dangerous use of the X-rays was in shoe fittings. X-rays, far stronger than most modern-day medical machines, were used to check whether a person's feet were in proper position. These fluoroscopes were widely used, many people excited to see the novelty, totally unaware of the ionizing radiation they were being exposed to. These machines were used well into the 1960s and would have undoubtedly caused a great deal of harm. This overuse and the lack of knowledge about X-rays led to many injuries as a result. Early uses of X-rays would take minutes or even hours for the image to be produced, meaning the exposed area was liable to be damaged. Hair loss, dying of skin, and blisters on the affected areas were widely reported. One notable example is that of William Levy, a man who had been shot in the head some years prior, who saw X-rays as a solution to the bullet's extraction. In July of 1896, he sat exposed to X-rays for 14 hours. By the next day, his head had blistered, his hair was falling out, and his ears and lips were inflamed. The first known death attributed to X-ray exposure was Clarence Daly, an assistant to Thomas Edison. Daly had worked much with X-rays, in particular for use in fluorescent lamps and fluoroscopes for medical use. His hand was often exposed and became severely damaged. In the end, the skin grafts failed to deal with the burns, leading it to be amputated. The cancers that developed would claim his life in October of 1904. There are images of X-ray technicians' hands, parts that were often overexposed. Many of those recorded being killed by X-ray exposure were listed as martyrs to science, but most of those worst affected were the ones operating the machinery. Another tragic example is that of Edmund Kells. Kells was a pioneer in X-rays for dentistry and carried out some of the earliest dental imaging with X-rays. His equipment required one's hands to be exposed to X-rays on a regular basis. Kells and many of his assistants met their ends to all manner of skin cancers. Kells had his fingers, hand, and arm amputated in hopes of stopping the cancers. In the end, he took his own life. In 1902, a doctor by the name of E.A. Codman compiled a list of X-ray related injuries. He noted a decrease in reported cases over the years between 1896 and 1901. This was, however, due to such injuries being underreported, seen as perhaps the price to pay for using X-rays and no longer a novelty. An example from 2006 shows the importance of proper training and safety precautions when dealing with X-rays. The Jean Monnet Hospital in France confirmed that due to inadequate training, 14 people were overexposed to X-rays, one of whom was dying from cancer, and 13 others required colostomies due to the damage done. It is thought that around 6 in 1,000 cancers are linked to X-ray exposure in some way, but thankfully, deaths directly associated with X-rays are incredibly rare, in large part due to our better understanding and training. And X-rays have also saved countless lives. CT scans use X-rays to locate tumours and all manner of health conditions. Today, X-rays are far safer, both for those who are operating and those who are exposed to them. The risk of contracting a cancer from exposure to X-rays for a patient are as low as 1 in 1 million. Technicians avoid exposure through protective screens or being able to leave the room entirely. The dose of radiation one is exposed to is far lower than early X-rays or fluoroscopes. As for Röntgen, he would go on to receive the first Nobel Prize in physics. However, the acclaim and fame were not at all welcome. He only went on to write 2 more papers on X-rays and refused to give any public exhibitions. He donated his Nobel Prize winnings to the Würzburg University and rejected several honours. Following the First World War and after being bankrupted by the Great Depression, he died of intestinal cancer in 1923. If you ever make your way to Würzburg, you can visit his laboratory within the university and see where the first experiments took place. Yet his legacy is more than just X-rays. By introducing the scientific world to X-rays, many more scientists studied the cathode rays and expanded our understanding. The difference between alpha and beta radiation was discovered not long after by Albert Rutherford. Our understanding of the subatomic world only grew. X-rays played a major role in the discovery of DNA. One could argue that the discovery of X-rays paved the way for a better understanding of the fabric of the universe. Yet, for the early pioneers, they suffered greatly from overexposure to the X-rays that would shape and improve our world.